Okay, thank you for joining. My name is Billy Abrams. I'm the Senior Vice President for Business Development of CSP Technologies. I've been with CSP for over 25 years since we developed our active polymer technology. And I'd like to talk to you today about using active packaging to optimize probiotic formulations by way of minimizing overage, reducing costs, and hopefully improving margins. So just quickly, a little information about Aptar CSP Technologies. So we joined the Aptar group back in the summer of 2018. CSP is really a material science specialist that earns its revenue through manufacturing packaging solutions, primarily packaging solutions, using our active polymer technology. Our main production facilities are in the United States in Auburn, Alabama, and in Niederbronn, France, which is outside of Strasbourg. We manufacture over 1 billion components annually, and with a very high focus on intellectual property. We have secured a number of patents about our technology. So to start with our agenda, we're going to talk about really who's responsible for strain stability when you're making potency claims about probiotic products, the critical role that water activity plays in maintaining probiotic stability, some of the consequences for failing to meet potency label claims. We'll do a real-life case study looking at the impact of packaging and the desiccant selection on water activity, stability, and cost. And lastly, we'll draw some conclusions from what we've learned from reviewing this information. So first of all, there are multiple players in the mix here, but there's the strain producers. There are the contract manufacturing organizations whose job is to get these strains into a finished format that the consumer can utilize, and then the brands. And each of them have some element of control impacting probiotic stability. So the strain providers themselves go to great lengths to manage and reduce water activity throughout their production processes. And what they're delivering to the CMO is often a freeze-dried, very low water activity powder. But then when the CMO comes into the mix, they have a number of aspects of their operations where they can impact the water activity, including blending and encapsulation. But then also they make a very important decision impacting the product because the CMO largely is choosing or providing options to the brand for protective packaging. And of course, the brand has the final decision in what packaging will be used. So now if we take a look at the role of water activity in probiotic stability, there have been a couple of academic papers presented around this. This was an article authored by some of the folks at Danisco DuPont Nutrition back a couple of years ago, where we know that the shelf life is typically companies are typically looking, let's say, for 24 months of protection. But now what they understand is that, listen, these probiotics are live microorganisms, and water activity is the main factor that influences probiotic stability. And typically, the companies are looking to maintain water activity levels with a maximum of 0.2, but ideally around 0.15 or below. And low water activity has been directly linked to, being able to meet label claims. There are certain containers that are certainly not very effective in mitigating moisture, containers made of PET, for instance. But in this paper, they ran studies with CSP containers and deemed them to be highly effective at maintaining low water activity level throughout the shelf life. And there is some data here that you can go through that indicates with this particular strain, LGG, that they were looking at. They looked at water activity levels ranging from 0.11 to 0.22 and 0.33, and then looking at the potency over time. And to the extent that you're able to maintain a lower water activity level, that directly led to improved levels of activity. Now, earlier, I noted that what the probiotic strain manufacturers are providing in terms of just raw strains, they have a very low water activity level, which is great. But in terms of finished formats, the CMOs are adding different ingredients, different excipients, maybe different bioactives or botanicals, and these materials are introducing latent moisture that will increase the water activity level and accelerate probiotic degradation. So we know the probiotics themselves start very, very dry, but other ingredients in the blends could be impacting water activity levels. So, and there are consequences to brands that launch products or commercialize products that do not meet their potency claims. So, well, what could happen? Listen, if you're making a claim about potency at the end of shelf life, and it's discovered that your products are not meeting their end of shelf life claim, well, that can have a lot of implications. You could lose business. You're having ineffective product, and your consumers may not be getting the benefit that your products can provide. You could certainly be subject to negative reviews in this day and age of where everyone is able to communicate with their peers about what's happening and experiences they've had with different products. You could potentially face regulatory action for having false labeling and be outed by a consumer watchdog who's looking to ensure that consumers are getting what they believe they're purchasing, potentially leading to even a class action lawsuit. And I think most impactful for these brands is a damaged reputation. So the bigger the brand, the more you have to lose, and the more important it is to ensure that you're safeguarding your product or being a good product steward, and you're meeting your end of shelf life claims. So, what can different organizations along the supply chain do? Well, they certainly to reduce their risk. So the strain providers, the CMOs, and the brands, they can try and control the environmental processing conditions to ensure they're taking whatever actions they can to reduce exposure to relative humidity. They can select and place in additional overages. They can select higher stability strains. In some cases, they can employ cold chain management throughout the shipping and storage. Now, that's very expensive to do that. And what they can do very effectively is utilize protective packaging that can withstand the real world challenges of elevated moisture and temperature, which they will see in shipment and storage and in commercial use in various zones of the world. So now let's look at a real life case study of the impact of packaging and the desiccant selection on water activity level, stability, and cost. So we'll take into account all of these scenarios and looking at, well, what are different options that are available? So we know that companies are often able to often sell probiotics in glass packaging or HDPE. What CSP offers, what we call our active vial or active bottle portfolio of products. And customers are typically in the amber glass bottles or in HDPE bottles, adding a drop-in desiccant. Of course, there are other customers that use blister packaging technology, sachet and stick packaging technology. And those solutions do lend themselves to the use of active polymer technology, which we'll talk about in a little bit. So here's a case study where a CMO in the United States provided CSP with data. They ran a comparative stability evaluation of a CSP active flip-top vial versus an HDPE bottle with desiccant. This was a 12-strain blend that was primarily lactobacillus and bifidobacterium. They ran their study at 22C, 40% RH, which is not the typical 25C. 25C, 60% RH, zone 2 ICH condition. I can't speak to exactly why they ran this study at 2240, but that's what they did. It was an 18-month study of size 1 capsules, 30-count capsules. They ran the CSP container versus an HDPE bottle with 2 grams of silica gel. The first graph we're going to show is the water activity over time. So in the HDPE bottle with the drop-in desiccant solution, the water activity started at around 0.15, and you can see it kind of goes up and down over time, but stays relatively flat. But compare and contrast that to the performance in CSP's active vial, where you can see the water activity continue to decrease over time. Well, that leads directly to increased potency. So if we look at what the potency was after 18 months in CSP, they had seen about a 30% reduction in potency, whereas with the alternative packaging, the HDPE bottle with desiccant, they saw about a 60% loss in potency. Well, that's a big differential. And if we think about it, if we think about, well, gee, if I know I'm going to lose 30% or I know I'm going to lose 60%, what would I start with? So if I put on my formulator hat and I say, well, gee, if I'm going to lose about 30% and I want to hit a 10 billion claim at the end of shelf life, all right, well, I need to start with about 14 billion CFUs. Conversely, if I'm going to lose about 60% of what I start with, then, geez, I better start with about 25 billion CFUs. Now, in this example, we don't have to go through all of the minutiae here in this slide. The purpose of this slide is to indicate basically how much are they spending to put the actives into each capsule. And in this example, they're spending about 3.5 to 4 cents of actives per capsule, with the majority of the cost coming from the two strains circled here, strains 6 and strain 8. But again, the takeaway is that there's about 3.5 to 4 cents of active per capsule. And I think in the world of probiotics, that's a relatively modestly cost product. So now if we start thinking about, well, what's the benefit then of using this active packaging solution? Well, if I can reduce my starting potency, the amount of overage I use, well, in this last example, based on the amount I could save in a 30 capsule product, I could save 36 cents in the ingredient costs themselves by using this more aggressive, this more protective packaging, the active container, relative to an HDPE bottle with desiccant. And that differential is linear. I get twice the financial benefit if I was in a 60 count bottle. So again, it's that initial reduction in overage that by using a package that has better moisture protection properties, even if the bottle is more expensive, there's tangible cost savings by being able to reduce overage by using these more sophisticated packaging solutions. And in this example, instead of starting with 25 billion CFUs and having about 15 billion of overage, the customer could start with about 14 billion CFUs and still meet their 10 billion end of shelf life claim. And that leads directly to tangible cost savings. Here's another example using the CSP active vial relative to packaging a capsule in a alu blister. So this was a study where the CMO, it was a acidophilus B-lactis blend. They set up their stability testing in 25C, 60% RH, zone 2 ICH, and zone 4 ICH, 30C, 65% RH. This was a 24-month study. They were using a size 1 HPMC capsule, and they were looking at performance, a comparative stability, putting these products into CSP active vials versus an alu blister. Now, many people would consider an alu blister to be the gold standard of moisture protection, but what you'll see here in the data is that's really not the case. The water activity level in an alu blister starts at about 0.12, started with the same in CSP. Over time, they saw a gradual increase in water activity level and a corresponding decrease in water activity with CSP, and corresponding potency differentials, again, very substantial. They saw about a 15% loss of potency with CSP, but a 56% loss in potency with the alu blister. That data was at the 25C, 60% RH. This data tells a similar story. This is data now that's been processed at 30C, 65% RH. And you can see that the differentials are even more stark. The water activity levels between the alu blister and the CSP solution have a very wide gap. And again, the corresponding potency differential it's really off the chart. They saw really precipitous declines in the alu-alu blister versus a much more modest loss in CSP. And if we did that same exercise of trying to quantify in terms of overage reduction, what you could start with if you were using CSP versus what you'd have to start with in alu-alu blisters, you'll see a very significant differential again. In the zone 2 ICH, you'd save about a penny per dose. And in the zone 4 ICH, you couldn't even really offer this product and meet a shelf life claim in an alu-alu blister. The amount of overage you were putting in is really, prohibitive. And it would be almost a 10-cent cost per difference per capsule to use an alu-alu blister instead of the CSP active container. So I think what you can see from this data is that there's really are tangible opportunities for formulation optimization by using these types of protective packaging to reduce initial overages and ultimately to save money, to improve quality and save cost. So if we go to the conclusions here, what have we learned? Why active packaging? First of all, you can reduce your overall product cost by reducing overage that's required to maintain potency and to meet your label claims. We can reduce the water activity level to improve product stability during the shelf life. Can potentially extend shelf life. Companies may have short dating now if they want to sell product into zone 4 or zone 4B countries, maybe 6 or 12 months, but why not get 18 or 24 months and extend your shelf life? Interestingly, this type of technology can enable new product formulations by enabling customers and brands to support innovation with different ingredients like flavors and botanicals and different excipients that may introduce latent moisture and increase water activity levels. They'd be enhancing the product, but today they would be introducing a culprit, latent moisture. But with these improved active packaging solutions, they can enable these new formulations. Lastly, something to consider is just the peace of mind. To ensure label claims for potency, there are numerous steps throughout the process where there's variation and there are opportunities for water activity to increase, including in the final product testing. So using these more robust packaging solutions can give brands the peace of mind that they're going to be, and they really can ensure that they're going to meet their potency claims on their labels. As we've presented data today, the CSP Active Vial portfolio of flip-top containers and desiccated bottles, along with our active film technology that can be used integrated into stick packs and sachets and blister packs, offer a unique technology to control moisture and reduce water activity over time. And this technology is available in multiple formats, whether it's rigid containers, or we can also support stick packs, sachets, blisters, and even probiotic oil drops. So I hope this information has been helpful to you. I hope you take it into consideration when you're looking at the overall product formulation and the final packaging, because all of them are impactful on your finished product decision. Thank you. I'm happy to take any questions. For people that didn't attend, feel free to contact me via email. I'd be happy to answer any questions you may have. Thank you for your time.